Okay, welcome back to our new topic. Here we will discuss about the classification of materials, basically engineering materials. Okay, engineering materials, the term itself denotes that some materials which are used for some engineering applications, basically focused to the engineering applications. So here, the engineering materials are basically classified into broadly into three major types. That is metals, ceramics, and polymers. Okay. Actually, the total classification we will see in the next slides, but it is broadly classified into these three, like metal, ceramics, and polymers. Okay. So here we can see that like this classification were not came in the contemporary era, which we have discussed in the initial slides. These three materials were developed during the time, or much developed during the time of modern era. Okay, and other thing like advanced materials and all were developed in the period of contemporary era. Okay, so these three are the broad classification. And the composite means it is a mixture or a blend, we can say it's blend of any of these two or three materials. Like metals and ceramics can form a composite, ceramic and polymer can form composite, polymer and metal also can form a composite. All the three together can also form, we can call it as a composite. Okay, so this is the detailed classification of the engineering materials, like metal, ceramic, polymer, composite, and semiconductors and biomaterials. So we will, in this section, we will see the details of each and every material and their basic bonding nature. To begin with, we can see what is a metal. Okay, we all know what you mean by a metal, and the basic difference of the metal with other type of materials is due to its basic structure, like basic mechanical, basic metallic bonds. So metallic element consists of some non-localized electrons. That is, these electrons are not bound to any particular atom. While studying the atomic or subatomic structure, we have seen that commonly an atom has a nucleus, which consists of neutron and proton, and some electrons revolving around it. But here, in case of metals, as we have studied, not a single like an electron does not belong to any particular proton. So it is like a few protons immersed in a sea of electrons. Okay, so lot of electrons are there. It will flow throughout the body. So this is the peculiarity of the metallic bonding. So non-localized free electrons are there, or in another term we will call it as a sea of electrons, or a protons immersed in a sea of electrons. Okay, so this peculiarity made metals or provided metals with very different or enhanced properties. Like so these character made the metal like directly attributed to this electron. So this made some of the extraordinary properties which ceramics and polymers does not have. Okay, some properties are like metals are extremely good conductors of electricity. If you take some ceramic or some what to say polymer, we can say that those things are not some good conductors of electricity. Not only electricity, heat. Okay, and these are not transparent to the visible light, because it will not allow any visible light to pass through it. Okay, so this is the peculiar characters of metals. And like polished metal surface has a lustrous glazing appearance. Few examples of metals, as you all know, like copper, gold, iron, sodium. So many metals are there. So in the crystal structure also we will come into detail about these metallic structures, metallic crystal structures. So the classification, for the exam point of view, if someone asks, you can write like metal or the metal alloys is classified into two, that is ferrous and non-ferrous. Ferrous means that contains of iron and iron compounds. It is classified into steel and cast iron. Cast irons widely divided into this, and steel with low alloy and high alloy. Low alloy consists of low, medium, and high carbon. So various applications. So just keep this in your mind. Here the non-ferrous part is not mentioned that much. You can, if you are interested, you can see it in the many internet sources are there. So you can just go through those, and you will get some idea. Okay, that's all about the metals. And now moving to the next section, that is ceramics. Okay, ceramics, as we all know, because in our grocery kitchen and many parts we will have this ceramic. Okay, ceramic is getting much more demand nowadays in comparison to the plastic and other fiber products due to health issues. So ceramic is an inorganic, non-metallic, and often crystalline oxide, nitride, or a carbide material. Okay, this is the basic definition of this ceramic. It's basically an inorganic and a non-metallic, type of thing. Inorganic means does not contain that CH hydrocarbon chain. Here it's a non-metallic thing. Non-metallic thing in the basically uh, non-metallic types of bonds are present here. Let's see how the bonding structures and all comes in here. The wide range of materials that falls within this classification include the ceramics that are composed of clay and minerals. Okay, like as I said before, the grocery and kitchen items which we have is all made of those clays, and some other mineral based ceramics are also available. Okay, so the two most common chemical bonds for ceramic materials are covalent bond and ionic. In few ceramics, we will see that some covalent bond exists, and in few we will see some ionic bond exists. So I explained the nature of covalent, ionic, and metallic bond through this classification itself. So let us see what is a covalent bond in detail from this figure. Okay, just see this figure. Okay, the first figure, consider two atoms like this one, A and B, or I call them as A and B, and these two atoms have atoms have a center of a positive neutron. Okay, sorry, positive nucleus, which consists of neutral neutron and positive protons, and it is this have a, an electron revolving around it. It can be a valence electrons also. So what they will do is that when a chemical reaction occurs, they will keep together and they will share the electrons. Okay, so they are in another manner we will call they are not selfish. They will share their electrons among themselves, and they will move together. Okay, they are not selfish, we will call. So covalent bonds are those bonds where two equal-minded atoms will come. Okay, and they are not selfish, they will share each other's electron. Okay, but in case of ionic bond, it is not like that. Two atoms, as we discussed before, come closer, and here a bonding occurs. How the bonding occurs? Here bonding occurs by transfer of one electron electron to another atom, from one atom to another. Here a transfer of electron, but here it is the sharing of electrons, here transfer of those, and one atom takes both the electrons and other one is lacking one electron. So the lacking atom will become a positive ion and other one will become a negative ion. Okay, so this is what ionic bond says. In other version, like the comic version, we will say that this these are the selfish. If two friends are coming and they are saying that like he is taking both the electrons, so here he is selfish, but here both the like both are not selfish, they have equal sharing mentality. Here they don't have the sharing mentality, this one is selfish, this one is clever. Okay, this is just for the for a comedy explanation was that. Like coming back to our subject, so let us see the nature, other things of these ceramic bondings. These materials are typically insulative to the passage of electricity and heat and are more resistant to the high temperature and harsh environments than metals and polymers. Okay, yet here like it will not allow, since no free electrons are there, they will not allow any passage of electricity or passage of heat throughout the metal. So they are also brittle in nature. So few examples are there, like silicon nitride, silicon carbide, alumina, zirconia, etc. Like these 3 4 2 3 2 all are suffix. Okay, sorry for this one. Please keep it in mind while you write the exam. You need to be careful, very much careful about this suffix. Okay, so this is all about ceramic. And like one more thing I want to explain, like I haven't explained this one, like it will not allow the electricity or heat. And like for space applications, for space shuttles which passes the Earth's atmosphere, it will face severe air resistance. So as a result, what will happen, severe heat will form on its surface of the spacecraft. And actually this spacecraft is protected by ceramic tiles, or pasted with ceramic or coated with ceramic tiles to protect the passengers or the astronauts who are controlling the spacecraft with insights. You all know the Kalpana Chawla's incident. Actually, it happened, that unfortunate incident happened due to the breaking of a single tile. NASA claimed that the single tile on the spacecraft was just got cracked, and from there the heat transferred inside, so that result in their death. So just keep all these things in your mind. This is the basic applications of the ceramic materials. So that's all about ceramics. And moving to the next classification is the polymer. I think many or almost all are aware about this polymeric materials. Okay, all this plastics comes under this category. So what's a polymer actually? Polymer, from the name itself, we can say that it is made of some small units. Okay, some small units, and it can be large molecules like or macromolecules, or some small micromolecules of a micromolecule. So it's a repeating subunits, and the small units is known as monomers. And these monomers together will create or bind together, and they will form a process known as polymerization. And with the result of the polymerization, polymers will form. Okay. The polymer include the familiar plastic and rubber materials, many of them. Many of them are organic compounds that are chemically based on carbon, hydrogen, and other elements. Okay, all these things. Okay. So the basic bonding nature present in the polymer is just covalent bonds or that selfish bonds. Selfish bond is not like technical name. Okay, for the explanation purpose only I am telling, don't write such things in the for your examination. Okay. And like polymers have low density and are extremely flexible in comparison to the ceramics and metals and all, like this metals are not brittle, not that much brittle, but here ceramics are brittle, but here it is not that much brittle, uh, not brittle at all. The polymers have got a large flexibility. So these are the major three classifications of the material, and this one shows the classification of the polymer. Polymers are classified basically into three, like based on the structure, based on molecular force, and based on the source. Okay, based on the structure it is classified into linear, cyclic, branched, or network. Okay, based on the molecular force it is classified into thermoplastic, thermosetting, elastomers, fibers, and based on the source it is divided into natural or synthetic. Synthetic means it is a man-made, so here it is classified into like addition and condensation. The base, the branch structures is shown here. These all things I think you have studied in your school times, and just please refresh those things. Uh, but if something for university exams or something, if it is coming, then it will be good. Okay. Now next is the composite. Composite, we told like it is a mixture of two base materials, like some metal or ceramics or polymers, okay, whatever it is. So the composite material is a material made from two or more constituent material with significantly different physical or chemical properties that, when combined, produce a material with characteristics different from the individual components. Okay, like some blend I told, I will explain it with this example. Let's take the example of a fiber glass. Okay, fiber glass. This is the fiber glass. You know the property, and you know the thing of ordinary glass. What's the ordinary glass? Ordinary glass has transparency in that one, but it is not flexible because it is very much brittle. If we apply a heavy load or good impact, it will just break down. Okay. So what we will do is that we will add the fiber along with this glass matrix to form this composite. So this is the fiber glass composite. So the benefit is that it will got the flexibility of the fiber and the transparency of that glass. So both properties are included. So it will form a new compound, new material. So such materials are known as the composites. Many composites are there. If you just check, you can see a lot of composites will be available in the market, and I think you need to, I will give a short assignment to check the what to say, to check this one, your the list of I think I need a small list of 5 composite materials which we can which we see daily. Okay, try to find it out. Okay. So next is the classification of other classification of material is the semiconductor. As I told, like these came uh, recent years, so it's somewhat called as advanced materials. So semiconductors have electrical properties that are intermediate between the electrical conductors and insulators. Okay, like it will be in between that of metals and that other ceramics or polymers or whatever it is. So insulator is there, and electrical conductors. So that's why it is named as semiconductors. It's much familiar for you all guys. Since you are taking good course in electrical and electronics, basics of electrical and electronics, and or mostly uh, you have gone through such kind of things in your high school, so I don't think I need much explanation for this one. So just refresh all those things also. And electrical characteristics of these materials are extremely sensitive to the presence of a minute concentration of an impurity atom. Like if we add some impurity atom, that conductivity, electrical conductivity and electrical characteristics dramatically changes. So devices made of semiconductors, notably silicons, are essential component of most electronic circuits. So now every electronic circuit is made from these silicon semiconductors. Okay, so the major, like 80 percentage of all the electronic circuits are made from this material named as silicon. Okay, silicon is an important material, and not only silicon, like germanium, gallium arsenide, all those materials can be used for this process, for this purposes. So coming to the next one, that is the biomaterials. Biomaterial actually, the definition says that it is a natural or a synthetic. It's alive or lifeless, whatever it may be, and usually made of multiple components that interact with biological system. It can interact with this biological system. So like, don't confuse the biomaterial with the biological material. Okay, for example, if you take your bone or the shell, okay, shell of some sea urchins or some sea aqua or marine animals, or horns, those things are horns of some animals, teeth, all those things are biological material. Don't compare that with biomaterial. Okay, that's the biggest mistake. In some websites also you can see telling these as the biomaterials. It's utter nonsense and it's utter error. Don't follow that one. Biomaterial is entirely different. Okay, biomaterial is something which can interact with the biological system. So that this portion actually you need to focus, which can interact with biological systems without providing any toxic effect. Okay, so these materials must not produce toxic substance and must be compatible with the body tissues, should not affect any body parts. Okay, recently, like, our knee pains are there for many people, and the knee replacement is also there, and all these knee replacement, and other replacements, body parts replacements, is done with the help of this biomaterial. It is a advanced or upcoming field. Many job opportunities are also coming in the future in this area. So it's a very wonderful area. Like, you can see that metal, ceramic, polymer, composite, anything can be used as a biomaterial. Like for this hip joint, if you see, like, it is a metal on polyethylene, that is metal on polymer interaction is happening here. Metal on metal type of joint is available, or ceramic on ceramic. This part is ceramic and this portion is ceramic. So ceramic on ceramic is also available. So many that kind of biomaterials are available in the market, and still research is going on to improve its properties and to reduce its cost for this one. Like, if you go to a hospital with some of your elderly having some knee pain, then those doctors, before the surgery, they will discuss with you about some material, like say that this material is of high quality and high cost. This material not that much quality, but it has a medium cost and all. So, like, you need to take a decision during that time. So this all depends on these kind of materials. So coming to the last part, this is the comes in the advanced material. Okay, like recently within last 10 or uh, like 20 or 30 years, within these 30 years these all these technologies have been developed. So it comes under the category of some advanced material which utilized high technology or high tech applications, uh, is known as advanced material. So high technology in the sense here measures to the computer, fiber optic system, the spacecraft, aircraft industry, military and rocket industry and all. So the materials used for the lasers, integrated circuit, the magnetic information storage, so liquid crystal displays which we can see in our TV, fiber optics for our strong and fast internet connections, like and thermal protection system which may be used for the space shuttles and all comes under this category of the advanced materials. And there's some smart materials like MR fluid, uh, and all will also comes under this one, which changes its rheology with the application of magnetic field, or electrorheological fluids are there which changes its viscosity or rheology with the application of an electric field, and all those things are there. So that's all about this material classification. And in the next video or next class we will see, or we will go through the atomic structures of various uh, molecules and elements. So thank you for the attention.